Simplifying radical expressions. The focused learning target is I can simplify radical expressions by using the product and quotient properties of square roots. A radical expression contains a radical such as a square root. The radicand, the expression under the radical sign, is in simplest form if no radicands have perfect square factors other than 1, no radicands contain fractions, no radicals appear in the denominator of a fraction. So we need to accomplish 1, 2, and 3 in order to get the radical expression in simplest form, right? So here we go. The product property of square roots and prime factorization can be used to simplify expressions involving irrational square roots. When you simplify radical expressions with variables, use absolute values to ensure non-negative results. Okay. So the product property for square roots. For any numbers a and b, where a is greater than 0 and b is greater than 0, the square root of a times b is equal to the square root of a times the square root of b. And that's the other way around as well, right? So what does that allow us to do? It allows us to take a square root expression, like square root of 180, and separate 180 into its various factors, right? So we could say 180 is equal to 2 times 2 times 3 times 3 times 5. That's equal to 180. How did we do that? Well, we know that 180 is even, so our first factor would be 2. And if we took a 2 out of 180, that's like us dividing 180 by 2. And that gives us 90, right? 90 is an even number as well, so we can get another 2 out of it. So 90 divided by 2 is 45. So now 45 is no longer an even number, so we can't get another factor of 2 out of it. But we can get a factor of 3 out of it, right? So we'll pull a 3 out of 45. That's like taking 45 and dividing it by 3. So that gives us, 15, right? Maybe I could do this with some work here on the side. So we will first get our 2 by taking 180 and dividing it by 2. Right? That gives us 90. 90 is even, so we could pull another 2 out of it. So that's like us dividing 90 by 2. So that's equal to 45. Right? 45 is not even, but we can pull a 3 out of it. So let's pull a 3 out of it. And that leaves us with 15. And the factors of 15 are 5 and 3. So 3 times 5. So we've pulled out all the factors of 180, starting with 2, and then moving on to 3, and so on. So anyhow, that's how they turn the square root of 180 into the square root of 2 times 2 times 3 times 3 times 5. Now we're looking for pairs, right, that are underneath the radical sign. And so we have a pair here, and we have a pair here. So we can rewrite this as the square root of 2 squared times the square root of 3 squared times square root of 5. Because there's only one 5, right? But there's 2 3's and there's 2 2's. Now from here, we can go ahead and take a 2 out of the square root because we have 2 factors of them under the square root here. So we got pull a 2 out. And we can pull a 3 out of this square root because we have 2 factors of 3 under this square root. So we can pull out a 3. So our final answer is going to be 2 times 3 times square root of 5, which is 6 times the square root of 5. So this is our simplified version. And so that's what we need to do here. All right, when we're given a expression with the square root, we need to break it down into its prime factors, right? And then we can pull out whatever we can pull out, right? So let's go ahead and try it over here. So 54 is even, so I can pull out a 2. So I'm going to go ahead and say square root of 2. And so if we take 54 and divide it by 2, that's going to give us 27. Yes, 27. Okay. Now, 27 is not even, so we can't pull out another 2. But 27 is evenly divisible by 3, so I'm going to pull a 3 out of it. So then that's making me divide 27 by 3, right? And so what does that equal? That equals 9. And 9 has 2 factors, right? It has 3 times 3. So I'm going to pull a 3 out of it and pull another 3 out of it, like so. All right. So now that we're here, right, we've turned 54 into its factors. And now we're looking for pairs to take them out of the square root sign, right? So we have a pair of 3's there, 2 factors of 3. So we can bring that out of our radical sign. So we have 3 times the square root of 2 times 3, which is 6. And so this is our simplified version of square root of 54. Let's put a box around this. Let's go ahead and try this next one over here. So the first step is to, break down 162 into its factors, so it's even, so we can pull a 2 out. So we'll pull a 2 out, and that's going to leave us with 162 divided by 2. That's 81. With 81, I could pull a 3 out of that, right? And so I'm going to divide that by 3, and that gives me 27. 27, I could pull a 3 out of that, so I'm going to divide that by 3. That's going to give me 9. And the factors of 9 are 3 times 3. So now I have all my factors of 162 under the square root, and you could double check that, right? You can do 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 54 times 3 is 162. Okay. So now we're looking for pairs, right? Factor pairs. We have one pair of 3's there, and we have one pair of 3's there, so we can pull out 3 and 3. So that's going to equal to 3 times 3, the 2 3's that we pulled out, 1 here and 1 there, times the square root of whatever's left over. And what's left over is our 2. So let's go ahead and simplify this further. 3 times 3 is 9 times the square root of 2. And that is my final simplified version of square root of 162.